Let's have a look. Let's see. So, one viewer so far. Hello. Okay. So, with that, yes, we had the 0.6.7 release. Apparently, there are regressions. I don't know how bad. Oh, great. It just made that one white. Why? Like, okay. Hang on. I think I just need to change that one and apply, and then change to whatever one dark theme default. Okay. No, that didn't work. Let's just grab that and let's start from here. So, release notes. That will be here. And we're already in a bunch of fixes actually. These test runner fixes were supposed to go into 0.6.7, and I thought they were in, but they were not. And then we were kind of like, there was this bad regression, or I think it was really bad with the git keep keep files that were not generated correctly. And I found another one. So the other one was like when you make an alias of something, which usually, well, you make an alias of type, then everything works as normal. But if you have an alias of a function, or a constant or an identifier, you're expecting that one to work as if it was normal, that you would have to prefix it, but the prefix never happened. So I was playing around with something called just frame scheduler. It's not really serious. If in this case, what I mean with a scheduler is basically you are posting event to this, queuing events asynchronously to this, and then some thread will occasionally, like in the beginning of the frame, maybe go through those and then run them. And there are some issues with that, like if you just iterate over the events while doing that and then add events as you are processing them, then things might go wrong. So you kind of have to have some locking, but you also have to have, like, keep that in mind, and then you have to have you want to have delayed events. So delayed events is basically say, let's run this in 5 minutes or 5 seconds. So the reason for this was not really to make something serious, but to kind of get a feeling for the standard library. So the problem with standard library is that if you're like me, you end up, writing stuff for the compiler all the time, and then occasionally you add stuff to the standard library, and you get pull requests for the standard library, and you get a lot of questions about the standard library. And whatever happens is that I tend to explain how the standard library works, but that doesn't mean that the standard library works the way it should. When I when I program myself, when I do like the advent of code or something, then of course, if I see something like this is not very convenient, I would immediately go and fix that. Well, maybe someone is writing something. No, okay. So let me know if like the if you can't hear or something like that. Okay. I mean, I'm just streaming this on my computer anyway, so without a microphone or anything, so I can understand if the sound is a bit sucks a bit. But I can try to improve that. Anyway, so the only way to kind of know what the problem is that you actually use it. And in this case, I wanted the frame scheduler, and then when like that's not enough. What I wanted to do is like let's run this little program that kind of runs this. So this is not even multi-threaded. It is just like let's init a scheduler and then queue some events and queue some delayed events, and then we just gonna process all of these events and then like just try to run until run for a while and see that we're sleeping. Eventually, we'll get those events. So let's see if I have a way to run this, and let's see if it runs. I didn't. It's not very important. I mean, it's boring. So we got the events and then sleep a bit, and then like we get another event there. Um, and I mean, the thing here was like, do I find something that's not very convenient that we can smoothen out and make easier? And there are. So um, if I look at this one, and now I was because this is in the Stun library, I couldn't really work with the the new generic syntax until I changed everything to use that. Unfortunately, um, a new generic syntax looks like this, by the way. So that would be like this, um, right? So that would be new syntax. I tried various ways of kind of making this work in a not too complicated way, but it kind of resists supporting both new way and the old way. And since I can't assume that everyone is like having the library and using the library with the uh, in with the new settings, I can't really fix this now. Anyway, so there's something new. So okay, there. Like normally, when you want to do something, you have here's a list. Like events is a list. You can see that up here, right? And the typical way things are named in the C3 Stun library is like init. So you have new init. Would be the normal way to do that. New init the reason why it's called new init is to highlight that this init is actually taking, implicitly taking an allocator. So that's what we want to say by doing this. But by saying new, right? So like this. But I'm using this one, okay? So the normal way, if you use this, not with the older, in like 6, the latest 6.7, you do like this, and that's how you would, Zig style, kind of initialize it if you had it as an explicit parameter. But this is kind of long. Even if you make this smaller, it's like kind of it's going to be like long. It's like maybe mem heap, right? But now you're typing a lot of things, and if you have a lot of inits, that's going to be not so nice. But it does highlight that this is an allocation. It's important that you know that, especially now, since we don't have any docs, right? Or the LSPs might not work as in a great way, and maybe there are not enough documentation. So you kind of need this with the names. It's nice. The alternative, what other things do, is like maybe they set, you know, ownership and stuff like that. But that doesn't really work in C3. Not because it's not possible to add ownership. It's just that ownership is a bad model in general for C3, because you would prefer to put things in the temp allocator if you can. So what about we discussed this on the in the channel, Discord channel about the standard library, and said like we could even have something like that, right? Now, what's mem? Well, that's where the new feature came in, and we look at what mem is defined it as. It's defined in mem allocator here, and we have this tlocal, which is basically the thread allocate. This is like the allocator, the heap allocator. So when you do like heap, this is the one that will default to. And I'm making an alias here, like call mem a thread allocator, and then I add this built-in. So built-in means that you can use this without the prefix. So rather than typing allocator, rather than doing this, you can just do mem. So mem becomes like this global that's everywhere. Kind of C-like, right? But anyway, so here we have mem, and then things kind of, it's even shorter than having new init, and kind of looks like, yeah, you initialize some memory. So maybe we could do it like this. I mean, the other thing that I could think of that would be actually very nice, but kind of impossible unless we change the syntax a lot, would be like having this. So let's say we had this, right? An exclamation mark, and now the exclamation mark means, oh, here there is some initialization that needs, you know, to be looked at, right? So it's an heap allocation or whatever. So anyway, that's that's the experiment here, right? To kind of see if init is good enough. Init plus mem. And so that's what I did here. So they just do the init mem or thing. What else then? Yeah, I found that we didn't have anything like let's do this in a lock, right? So that was an obvious thing to kind of have this the mutex, right? So this the mutex, and then we have this macro that kind of locks and then unlocks. What else? Was there anything? Yeah, so when I add these events, right, these delayed events, I wanted to, you know, have, okay, I use the clock, not the time, but I want to take like, okay, let's have the clock, let's add a duration, like a delay from, you know, I think that's, yeah, that was milliseconds, right? Duration. I don't recall. There is a function to create these different times. So that's what I use here. So I basically set time seconds, set time milliseconds. And those creates durations. Anyway, back to this. So I wanted to add something to this current time. I didn't have that either, and that was like also an obvious thing that could be helpful in case you play around with that. So what my point is here is like really, oh, and I wanted to anatomically store a boolean, and then turns out that I didn't I was just thinking about like, okay, integers and floats and pointers, those could be stored autonomically. I didn't think of like bool being a different thing, right? So for everyone else, you know, encountering this, I mean, I can understand that their reaction is like, oh, you can't atomically store a boolean. Oh, there's some limitation or something like that, even though there isn't, you know. So I'm going to encourage everyone to, when they encounter something like this, right? It's fine to kind of, you know, write your own tool functions, write your own kind of helper functions, and then, you know, contribute those, because those are actually something you need. Those are actually something that's like battle hardened eventually. Not the ones that you immediately think of and then just put somewhere and then maybe you didn't use it, but the ones you end up using over and over again. Like those are the ones you should go into the library. Um, and we have some things that's pretty gnarly too. So we're gonna go into that. So let's look at the path, right? So the idea with path here, which is just like, if you look at path, it's basically just a string and the environment. And what it does is that it keeps track of, this is like a Windows sorry about that. Windows path, or this is a POSIX path, and depending on what it is, we're just going to handle things differently, right? And this can be useful if you are doing stuff. I mean, what you're writing for is going to be like whatever environment it is, but you might have POSIX strings when you go into other environments and so on. So you want that kind of functionality. But this API, these are fine. Like mostly these are fine. But the API for the rest of the shit here, like you get a path which you have to allocate to get, and then you do an ls on that path, which is completely bonkers because, I mean, you don't need that path, you don't use them anymore. I mean, and then you get the path list after that. Okay, yes, there's a list of paths, and the funny thing about that one, I think it's not the full path either. So it's like it's kind of bad. But I was thinking of like, oh, maybe I want to do something better with this, like have something where you kind of give me the files. Sorry, I have to really, I have to yawn a bit. I'm kind of, it's late and I'm still a bit, my cold is still here. But these functions are fine, you know. So maybe this should be like, oh, here you have a string. Yeah, great. You can like put it in there, and then you can, you know, verify that this is, you know, here you get a new string, because you kind of made the absolute version of whatever. But my thought when I did this, like, yeah, you have the string, you have the path, and once you have the path, it kind of always works, and you don't have to think about normalizing it, and it's just gonna be like all nice. But then you have all these allocations anyway. Here, like this is grabbing you, giving you the absolute path, giving your path. So if you already have, you know, an absolute path, then we just allocate a new path. And this is fine if you have like a temp allocator. But if people start using this with the heap allocator, it's just not nice, right? Even with a temp allocator, this is going to be like a lot of copies back and forth. So this API is not great. And I was doing something, I don't remember what, but I was using these paths for something. And I was like, yeah, well, this is annoying, right? So it's not the code in here. It's like how you use it. Oh, I know what I used it for, right? So I was doing the test runner the other day. This test, let me see, test suite runner, right? And this is like a port from Python. So yeah, it's not so great. But you look at this, like temp append. It's temp new. I use the temp allocator all the time here, but it's like, yeah, temp new. I mean, this one, like allocating a run file on the heap, which kind of collects something that's used for a long time. That makes perfect sense, but like as I have as a pointer. But if you have to, look at this file open path. So we take the file name, we take the original directory, we append the file name, and uh, get the file in there because our file name is without a path or whatever. So all of this is kind of, well, not so nice. So this is what I kind of need to work on. I need to have some program to kind of make this convenient, because convenience is, it's so helpful when you can focus on the goddamn problem. I had a bit of chocolate cake. That's why I'm kind of eating as we are talking, as I'm talking. Oh, I'll see if someone wrote something. I personally prefer either init.mem or init. Get well, thank you. So, thank you a lot. So, anyway, these kind of things is something I feel like I really need to do now. Like it's also easy to kind of get um, do things that are kind of half-assed, not quite working. Another recent suggestion by let's see here, who's who was it that suggested this? Let me look at the repo. Okay, so we have Alex Viden, Alexander Vedenev, or something, right? Suggested that we kind of collect. I think what's Alex? Let me see. Yeah. So basically, that we collect a lot of the common faults and just put them in a single place, like common excuses. Now, there are good and bad things about that. Because obviously, if we put it like here, we have the typical search result missing. I remember this one. I remember this one, right? Because I can end up using this a lot. And there's another one, it's like iterator no more element. And I sometimes mistype that one, no more elements, right? We have this one here, like iterator result no more element. And both of them are like in the built-in, right? So it's the built-in. This one is very useful if you haven't seen this one. This one has the all the cool stuff. Um, if you want to hack some things, here's where you create a new make. Here's where you make the breakpoint. Here's you kind of take something any that is distinct and then grab the thing that's inside. Here's the bit cost that allows us to cost anything else. Um, Here is enums going back and forth from enums, a bit of setting expect and so on, and prefetch and swizzle, where you can take. It's like the first one is the vector, and then you get like the indexes to kind of swizzle with. So and then in what order it should be. And here's catch and okay if you've seen those. And there are these find to upper to lower, which is like built in compile time. These work at compile time. And we have the generic hash, and then the hash functions, and also the one that get the frame address, and maybe that shouldn't be in here. And finally, we have like the sig. These should probably be. Oh, I'm kind of got interrupted here. Hang on, I'm just going to see what someone says. So I have a daughter who's asking if she can drink something here, some soda, and I have no idea. Anyway, she left. So um, so to go back, this is kind of interesting. At least the beginning of this one built in. And we'll have the runtime as well. So if you ever wanted to cause something, bit cause some, do something funky with the slice, and you don't want to go by way of going and casting something to another pointer, you can go to, let's see, a runtime, right? So we have the any type, which looks like that, and slice there. Yeah, that one isn't long. Yes. So I think also like maybe people are not aware that there are things like the string iterator that would iterate over um, these code points and so on, but they are there. So, but making these like accessible and useful. I mean, I might use this string iterator, and then I just suddenly decide that yeah, this one one is bad, right? And I mean, the string iterator, we have a special hash map iterator that is allows us to kind of go one way through the array. So the only problem we have with a string iterator like this is that it doesn't know the length, but we can kind of cache that if we want to. So it could be it could be made to work. So we basically, see what the length is. Look, here we have it. We are looking at the length of that. And we could just like really look at the length up front of everything, and then well, there are things that could be done there. But if I do that without having a use case, I'll probably mess it up again, in the sense that the API, the way the function works might not be like how you envision that, like how people will want to use it. So, I mean, if you clone and here's something, have you done this? Like, this is super useful. You have an any, you don't know what's in there, but you want to make a copy of that thing. Well, you can do that. You don't need to know what's in there. So that's the way, how the any list works. Where the any list is like you can put anything in that list, and we'll manage it. It won't do any fancy stuff like deep copying, but it will do um, shallow copying, which is often like what you want, right? So you can put any size of things in there. Um, okay, yeah. So useful, but maybe not perfect in like how we use it, and that's also I think like the way why I wanted to change this into this kind of generic, even though it kind of broke the other way it worked with the like if we have that we can't do this kind of foo as this foo. This is what we used to have, and now it's not possible anymore. We need this syntax. Otherwise, this would be ambiguous. There was some other thing. Let's see. Yeah, and removing this thing, right? Why would I remove this? Again, removing this expression block is like no. People are rarely using it. When when you see it and you haven't like seen it before, you don't know how it works, right? It's just confusing, and it doesn't bring that much power. Was my like I realized that I wasn't like I love that feature, but I also realized that most of the time I shouldn't have used it. It's like lambdas in Java, like using map in Java. That's almost always like a map and collect and stuff like that. Functional type in Java. When it came out like Java 8, and like, oh, let's try this. Oh, we can do like this, like a one liner. But the one liner was so much less readable than the loop. Yeah, I mean, people are like, I'll have to take this like this example, right? Let's, you know, let's do something like you have an array. Now I'm just going to write up an array of 10 elements, right? And I'm just going to have like a random element number 6 is like the one we want to go for. But I mean, this is from somewhere else. Okay, so now we want to do what we want to do is like we want to look into this, and then in C this will be like okay x. So we're going to I is going to be like 0, and I is going to be like whatever length is. I mean, how to get the length for something, and then we're like okay 10, like a length. Let me just write this up. So and so length is like typically separate, right? Like I'm going to write a method. So we have something like this, and we're going to have like a index of find, x in we do it the C way, right? So we have x and we have 10, right? So and then we'll print that. Print index. Yeah, that's enough. Now our find method in C would typically look like maybe something like this. So we have this int array, right, and array, and then we have like int elements count. So after the type, and then we're going to do for int 0 count plus, and then we like if ri equals find. We have to have the needle, right? If that one is found, then return I. slice, we return -1. So this is the typical search, right? And you sometimes, oh, I did something wrong here. Let's see here. So find something 10, one more element. Yeah, I'm gonna look for 3. And so here it's going to be 6, and if I look for 4, then it's not going to be found, so it's just going to be -1. So we can do this all the time, right? But for the functional, now people would be like, okay, we can have an optional result, like this, right? No, just writing hypothetical thing, right? So the index is going to be like, and then we can have we're going to have x, and then we're going to map it, and then we're going to have like something that might look like v equals 3, and then something return. We have to have this too, something like this, and then something, right? Foo here, and then we can get this right there. And then when you have that, you are going to have to unpack it, right? So this is longer, but it's straightforward. So what happens in when you have slices? So is that this goes away, right? And now this becomes just for each, and we have the value, and we have the array, and now if we want, we can write it if v equals needle return I. Otherwise it's -1. We can have -1, right, if you want to. And everyone is seeing that we can make like almost a single liner by doing this, right? And if we want to have an error output, we could do like this instead. So we have this search result missing. Now the reason why we want that is that we can do things. We can like do this, like we have let's do our find 2, right? And we have the x, and we have a slice. It's going to be a slice, and then we're just going to look for 3, right? But this one is going to give us an optional. So let's grab, if there's an optional, let's return -1. So then in this case, like, we have exactly the same behavior. So let's just verify that. No. Oh yeah. Okay. So here's something people should know. You can do that. So if you don't like that it's like you said, you can just retype it. I know it doesn't work like that in other languages. I think that's important. Anyway, so now it works, right? And we can also do it differently, handle this in a different way if we want to. We can have any other default we want. We can have like 99 if you want that, if it's a missing thing. If I had this one, we might want 99 instead as a default. And we can, as an alternative, we can rethrow if it wasn't expected, or we can do like, okay, if it's not the one that we want, then we can catch this and just return maybe from like this function, right? And then we have again like this. So in that case, we are handling the -1 in a way. It's like a value, but it's kind of like in this case, like if index equals -1, then we return return. So these are equivalent, and that's why this implicit unwrapping of this one is important. So now it should still work, like give me a 6 in both of them, right? But if I do something like this here, we know it's going to exit early because we had to return. And yeah, and if we have it here, again, this will exit, so it should just print the second one. Anyway, that was like a roundabout way to say like how I find this much better than having, a feature, a bunch of features even, to do it in different ways. I mean, it's one thing if your language is going to build up just having these immutable things, then you want the kind of map and things. But if you have things mutable, why then pretend that you want something immutable? And the thing is that if you have this, it kind of is pretty much the same if you're here, right? You can do. Now we're talking about this one, right? So I guess like the advantage of this is that you could put this code inside of here. And then we know the needle, right? And then it could be like we could have this in like this one works. It's the same thing, exactly the same thing. So we can remove that one, and now will work. I think expression blocks have been deprecated. Yes, it has been. Okay, was that an error? Wait, that was not intentional. That was very much not intentional. No, I cannot. Did I set some? Oh, this array. So let's just put this one to x, right? So that was one. Why I was like, did I? Okay, so now it worked, right? But I can show you how this is done. In the case that we always want to find something, right? The normal case, we want to find it, and otherwise we want to return. So then we could do, we can do this, and then if it's not there, let's return. And here we have to, have the value of outside. We can make it no init, but that's as much as need. And of course here you would have to have a little longer, because you would want to, or yeah, you would want to have like this, right? So we have index2 equals I break, and now we want to break out all of this outer, right? Not super elegant, but we don't need that one anymore, so right. And we can even, not have this. Oh, I didn't use the index2. We can have this, and we get the same result, okay, but we could also, if this was something that happened, then maybe we would just have, we're talking about the code looking like that, right? So we have something like this. Now we can print it, and then we write to other. And then if you want to compress this, I guess you can. Someone was suggesting this, which is like a way to make this not having to have the outer one. So if you had an else, which is basically, okay, we exited, I think it's that way anyway. So if I just go and then exit in a normal, I think I go into this one. I'm not sure. I don't remember how the Python version worked. But I see here this also works, right? We didn't need this. We didn't need that either. Yeah. So anyway, I think if you have the tools and you understand the for each, then you can always solve things with those tools. And you kind of want that toolkit to not be too big, because if the toolkit is too big, then when you're facing these kind of problems, this is not much longer and it's not much harder to understand than the solution with the this solution. So let me just copy this one. So we have this, right, this solution, and then we'll go back to whatever we had before with the expression block, right? So here is that one, right? We have this. Yeah, we're supposed to print this. Okay, so um, that is the expression block version, and here's the version where you just search with for each, and then there's the other one where you kind of actually do something if you don't catch it. Um, so in this case, we don't need to do anything because the return is going to be anyway. Um, but I mean, this one is more compact, right? Certainly more compact, but also um, people kind of understand this, and often, and being able to do this, doing have this outer to kind of wrap things in a second time. Um, it kind of solves the problem. Not super elegant, but it kind of works. I actually wanted this one mostly because I wanted to do things like if something something, then return like X, and if something something something, then return Y. Otherwise, here's the code. Um, and and usually, actually, my cases were like this. I didn't actually have anything that returns. I just want to jump. But then you have do. You can also have do with a label. In C, it's not as nice because you would have to do like I do this actually in C. So I'll like go to done, um, and go to done. So this kind of outer is a version of that, right? We could have imagined this written with goto, um, and if you are used to goto, then this is the solution. I think that it makes more sense. Uh, like this. No, C3 doesn't have goto, but let's like think about that one. It would go like go to done. I was going to say don't call it that. And otherwise we are going to have a return, and then we had done, and then we have the other code here. But the reason why I don't like that is like the flow here is kind of hard to read sometimes. To be honest, it's kind of this one become like almost hackish, that you would like to have like okay go to foo, right, and then foo should have the return, because then both are like go tos, and that makes more sense. If you have a do, I think the do is nicer in this case. Anyway, kind of boring discussion, but the thing is that I want to have less things that people have to memorize, and the things that you are using is going to need to be like fun and nice to use. So going back to the thing about memory management, then so we have file. So that one is not bad. So if I think maybe it's bad, but I mean, let me have IO instead of iOS. Okay, so we have this particular thing. So we have like open path, exists. This was actually a new thing I added. And you see again, we have going to have to use path, and we go by path by way of path, which is kind of gnarly and pleasant. But we have some nice things, right? We have, is this a file? Get the size and stuff like that. And it's not. And here comes like the things about like what's a method and what isn't. So file is, that's like the borderline, kind of borderline here. You kind of get the right byte and close on the object itself, or on the value itself, even though it's kind of doing something global. But that was not what I wanted to show you. I want to show you load buffer and load new. So again here, load new would load something, then I'll allocate memory for it. Sorry. Save is much easier. Save is just to save, right? I wonder if this is right. Written here, if something was written, if written is always going to be like right, it's going to send me the end of the problem from here. So this one is going to be like an error. So this was always going to be positive. Okay, so let me show you the API for this. So we actually have this kind of this file, right? We have it here already. So the bug stuff is called the bug stuff. So I can just now let's see what I imported. So I'm importing the entire standard library, right? For convenience here, what you shouldn't do if you want good code completion. But let me just take the file and I want to load new. And then I want to take this debug stuff, C3. I'm going to get like this data here from there. Let's just panic if we can't find it. And then I'm going to print that one. So I'm going to print it. I'm just not. Well, I might print it as hex. So can do like this. And then we should always free this, right? Is the correct thing to do. Let's run this and see what kind of data we have in our file. And we see that this is the representation here. EF, PBB. Does this look like our code? CRA, some line. But this looks like start of the. These first things here look weird. That's the order, right? Byte order. Let's see. Well, we can print this one too. So now let's pretend it's not that, and then we get this thing here. It's kind of worrying that the data in the beginning there did look a bit weird. EFB. Well, maybe it's wrong. Maybe something's wrong with this. Maybe someone has an idea. Right. What is C3? Yes, C3 is a programming language that I've written, yes. Okay, so without doing too much with this kind of weird though. Let's make a bunch of spaces in the beginning. I didn't expect it to put these markers in the beginning here, actually, but apparently I have them. Let's print those again. All right. Anyway, um, so this thing is fairly straightforward. But what we could do would be like load mem like that, right? And now I think that was the order. Maybe just check. Load. No, there isn't a load file that has the allocator first. But we can make one. We can make load, right? And then we put the allocator first. And then the file name. And then we just load new file name allocator, right? And that works. We can also load temp. In that case, we don't free it. Okay, we don't have any memory mem to pass either. Oh, we get something similar here. We get the same thing here. So what else? So these are like thoughts on also on how to do this loading and things like that. But this is also like kind of a useful function. Like, is the first name you kind of think of? Is it like file? Let's load it. And yeah, you might need to put in memory allocator. It's a mem, right? And that kind of makes sense. In the case where it wouldn't be being one, I think you would have thought like, okay, I allocate this data somehow. If you don't, unless you come from a language where you don't need to think about memory. But anyway, maybe it should be like t load, right? Temp load. Have like t, just have that, and that would be to load something temporary, maybe. But just have it look a bit nicer. Load mem, yeah, kind of. There's also this, you could have it afterwards, I guess. I know, maybe if it's in the front, it's kind of can be uniform. The problem is like when you have init, you will have these optional values, and then if you put those first, then you have to have the named argument in the end. So yeah, mem is not a good thing, but I don't know. It could be like alloc or I don't know, heap. Something like that could work too. But it's not going to be necessarily be the heap. It could be anything here. So, I mean, even the heap the heap allocation doesn't need to be the heap allocator. It could be like the arena allocator. So maybe mem is the best thing here, even though it's not that good. I don't know. Oh, so I don't really have. That's like a kind of a rambling sort of thing for today. Maybe we can check in some of that. We can have, what did I do? This one isn't useful. This one isn't useful either. So let's just dump those. So let's see here. I don't think I made any changes. Right, I'm just looking at the. You're not seeing this. This is like I'm in the um, commit changes thing. So what I'm going to do is kind of add this load function. Didn't I make it? Yeah, so the load function is going to be going there. So file load added. It's going to not going to write anything particular about that. Just I need to run the test runner to test everything. Just to be sure that I didn't break anything. Any questions so far? Okay, so is it intended that passing a const to an input parameter compiles while passing it to an out parameter doesn't? A const and in-out parameter. What is a const? A constant value. The only thing that should go in an in-out parameter should be no. I don't think an in-out should compile. No, it should be just like we can have a look at that. We can have a look at that. Let's see. There's a function here, so there is a parameter or something. Parse simma parameter check parameter type. Let's see what that is. No. It's something with a function signature, I think. No, the call. Sorry. Simma call. Analyze function invocation. Oh, here it is. So an out parameter cannot be pasted into a macro. An in parameter can be pasted in a macro. Okay. A const parameter cannot be pasted in a macro as an out or in out argument. Let's fix that. Hang on. Is it that in out is just treated as anything? Let's see. So in out, but in out isn't. So see here where we assign this thing. Here we have so in out is not going to have a either, right? So what we can do is this, right? So now it's actually more correct. So let's see here. If it's an and take all not an in, and it's an in but it's not an out. And then let's see. So and then we're here. so we have, now we can just check for this one. And then an out parameter. And not ident out. See here. So it's an out parameter and it's not an in parameter. And the parameter is an in parameter. As an in, our parameter cannot be passed as an int or in out argument. Okay. And then we have the second case here, which is similar, where you have an in parameter and it's not an out parameter. An in parameter may not be passed as an out. Oh yeah, so that's correct. All right, so we have some rules here. So out parameters and it's not an out parameter and it's an in okay. So it's not an out parameter and so it is an out parameter or it's, let's see here, there's a case where it's like we have the in parameter, so it's an out parameter may not be read, but it might be an out parameter and an in parameter, and it's an in parameter or in param. And then similarly we have this case. So okay, so this, okay, this is the same case. So let's look at the in parameters. And or decl var out param. I think this is correct, so we'll just run the tests on this. So now the test suite is running on this. Let's see if we can get, oh, it's long. It's real slow now. And then the other questions while we are talking about this. Only one viewer left. So I think everyone is kind of getting tired now. It's late here at least. Maybe if we have people from the US, it's more of a middle of the day, I guess. Or in somewhere in Asia, in East Asia, that we are getting to the morning right now, right? Sorry. So so far so good, but I'll fix this. I'll check this in later. So probably not now. Yeah, unless there are any other questions, I'm going to wrap this up here. So, thank you for listening, and have a good night.